Okay, so we're going to talk about some of the basics of C++ code here. There's a whole bunch of stuff. That's a really broad topic. And so we're going to start by just talking about what it means to write code for the Arduino and what is required of code for the Arduino and kind of some of the basic functions, and we'll expand from there. Okay? And so the first thing to note is what a function is. A function is basically some set of lines of code that are packaged together in this thing called a function, and when that function is called, it executes those lines of code. And so when we write code for the Arduino, we have two kind of main pre-built functions that always run. We have this function here called void setup, and so the setup function is a function that runs first, and then a loop function is a function that runs continuously after. And so when you power on the Arduino, this function is going to run first. It's going to carry out these lines of code in here, and then it's going to go down to this function. It's going to carry out these lines of code, and when it runs off the end here, it's going to jump back up to the top and do it again repeatedly. Okay, now there's some labeling here. It says void in front of this for both of them. We're not going to worry quite yet what that means, but that's referring to the return type for a function. And so yeah, without getting too far ahead of ourselves, you could think of a return type as like the thing that the function does. So functions can be used to do calculations. They can be used to manipulate data of some type. And so this is telling us what kind of data that we can expect to see back from the function. When it says void, what that tells us is that this function doesn't provide any data, doesn't send any data back. Okay, so we have two functions, the setup function and we have the loop function, and those always run, and within them we have kind of these different lines. You'll also notice a whole bunch of gray text. We have some gray text here. So the setup function runs once when you press reset or power the board, and then we initialize here the digital pin 13 as an output. So you can see that these gray lines are kind of explaining to us what's going on. Now gray lines of code that follow these two backslashes, so if I want to make a gray line of code, I make those two backslashes, and what that is, that represents what we call a comment. A comment is a way that we can annotate or document our code without actually affecting what it does. And so if I want to add a line somewhere, and so say if I want to say it right here that now the pin will turn off or something like that. So I've added that comment there. It doesn't do anything to affect the code, but it allows me to make a note about what's going on. Okay, if instead of doing one line I want to make a multi-line comment, then I use this symbol here and this symbol here. And so let's say in this loop that I wanted to take out these lines of code here just to see what happens without them. I would make that opening one and the closing one, and now those lines of code all turn gray. They're not going to be used as when the loop function runs. Now that loop function will run as basically will be empty. Okay, and so those are some tools that we can use with the functions. And now we have a couple other things. We have this function here in the setup, so that means this will only be called once because it happens as part of the setup, where we say pin mode with the number 13 and the word output. And so pin mode is another function, and so this is a function that doesn't automatically happen, but this is one that we want to call to do some type of thing. Okay, and you'll notice that this line ends with a semicolon. So anytime we're writing a line of code that's not a function, we want to end it with a semicolon. So when we create the function or define the function, we have these open and closing brackets, but when it's just another line of code, we always have the semicolon. And the great thing about the compiler is, if you forget that semicolon, it's going to remind you, right? When you go to verify that code or when you go to run that code, it will give you a reminder that you forgot a semicolon. So it's not going to let you forget that on accident. It will be ready to remind you there. Okay? So we fixed it and we're good there. So anyway, the pin mode function here, coming back to that, is taking pin 13 and it's telling it to be an output. And alternatively, if we wanted to get information from that pin, we could set it to be an input. Now we're not doing that right now, but that's something we can do later. We could also change it. So this is just referencing one of the labeled pins on the Arduino board, 1, 2, 3, etc. all the way to 13. Well, we can change that to be 10, 11, 5, whichever we want. If we come back here to our image, right, you can see we have all of these numbers. So this is pin 13 right here. And so what we're telling it is pin 13, we're setting this so it's going to be an output that we are going to control it, and it's sending information out. Okay, and in this case, the information we're sending out is, of course, this digital write function. Okay, and we'll get to that in a second. So we've learned we have this setup function, loop function that are always running, and then we have these other functions that we can call when we want them to run. And so we have this pin mode function that we're calling here. We have to call this function if we want to use the digital write function on that pin. If for some reason this line of code wasn't there and we did the digital write, then it wouldn't behave the way we expected it to. Okay? And so if, let's say, we were blinking an LED and it was really dim when it was blinking, that would be, one of the things that we want to look at is to see if we forgot to set that pin as an output. Okay? Coming down to the loop now, we have some additional functions that we're calling. We're calling this function digital write, and then with the number 13 and the word high. And so essentially we're taking this pin and we're switching that one on. And so it's basically we're turning it on, setting it to high, so setting it to 5 volts. Okay? And then this delay function, it has the 2000 there, and it says actually wait for a second. It's actually 2 seconds. So the number here is the number of milliseconds that you delay, and so in the case of 2000, what we're doing is we're freezing the processor for 2000 milliseconds, which is the equivalent of 2 seconds. So we turn it on, we freeze it for 2 seconds, then we turn it off, and then we freeze it for 2 seconds. So we have the digital write function, we have the delay function. Now a note with this delay function, it's something we're going to call a blocking function that kind of stops the processor from doing anything else in the meantime. Now we can break through that using something called an interrupt, but the problem with using delays is they don't allow you to do anything else at the same time, and they kind of stop everything else from happening. And so there's ways that we can work around that, which we'll learn about later. But this causes time to pass. But let's say we're trying to press a button to change something. Well, if we're waiting 2 seconds, then we can't check to see if that button's pressed or not during that time. Okay? If we were to remove this line, where we did digital write high and then digital write low and then we waited, we turn the light on and then we turn the light off, assuming of course there's an LED connected to this pin, and then we wait 2 seconds. Well, we turn it on and then back off so fast that we would never be able to see that it was ever turned on. Okay, so it would just look like it stayed off the whole time, or it might look really, really dim if we did see it. Okay, and the same if we left off this delay here. So if we read this line of code, digital write 13 high, delay 2000, digital write low, it's immediately going to cycle back around to the start, and it's going to call that digital write high again. And so it would be like it just turned right back on as soon as we turned it off. We wouldn't be able to see that we even turned it off. Okay, and so in order for us to see a change that happened, we have to add that delay in for it to register for us, because otherwise it happens so fast we can't tell. Okay, and so anytime you want something to happen simultaneously, let's say we get into having multiple LEDs. Well, if we use digital write again with, say, another pin, let's say 10, and then we want to do the blink sketch here with that one as well. So this would allow us to turn them on at the same time by putting one line after the other before the delay. And so all these things, they don't happen simultaneously, but they happen so fast that it appears to us that they were simultaneously. So it would look to us like these two lines were executed at the same time. So the last thing to note is that it's going to execute code from line 1 working down. And so anything up here above the setup is going to be code that is called beforehand. And really, I think technically anything that we even have just on this page outside of those functions will happen first, and then it will call the setup function, and then it will call the loop function. Okay, and so this is the basic building block. We're going to kind of build off of it from there. That was a lot of information. Hopefully it made sense. And the next step is for you to take some time to mess around with it and see if you can kind of understand it and learn from it. Okay?